Good morning, everybody. Today we're going to be working on our square root property. So I've got my page pulled up. Let me get my pen ready. Here we go. Alright, so we're talking about square root property, and when we're talking about square root property, we're talking about quadratics. So we've got an x squared, so we're going to have x squared, and we're going to have to solve these. And there are different equations. We're going to learn a couple of different ways to solve these. The first being the square root property. So you'll see you have an equation, x squared equals 25. So I want to solve this equation, which means I want to get answers for x. I want to find out what number squared equal 25. So in order to solve this equation, if I've got x squared equals 25, the square root property says I can take the square root of both sides and it be legal. Again, remember, whatever you do to one side, you do to the other. Well, if I take the square root of x squared, you know that's going to come out as an x, because remember, there's an imaginary 2 in the pocket. You divide 2 divided by 2, so that'd be x to the 1. Now, I think about square root of 25. When we're talking about solving equations, we need to think about both the positives and the negatives. So if I take square root of 25, that's going to be positive 5 and negative 5. And you may or may not be able to use that symbol in ALEX. So if you were going to list the answers, I would list 5 and negative 5. Because let's think about this if I went back to check it. If I went back to check, 5 squared equals 25, because 5 times 5. And negative 5 squared also equals 25, because negative 5 times negative 5 equals 25. So on these, you have to think about your positives and your negative answers. Alright, so the square root property states that the solutions of an equation of form x squared equals k, where k is a real number, are positive and negative. Alright, so if you'll see down here, solve the equation x squared equals 81, so square root both sides. So x equals plus or minus 9, or 9 and negative 9. Not so bad. Now on these, what I'm doing is I'm isolating the x squared part and I'm putting the number on the other side. So again, we're going to find a couple of different ways to work these, so you'll see different ways. Alright, x squared equals 17. So square root both sides. Now this time, if you get x come out, there's no perfect square that goes into 17, so that's just going to be plus or minus square root of 17. That's all you can do with it. You can't simplify it anymore. But the next one, y squared equals 50, if I square root both sides, I get y equals plus or minus the square root of 50. Well, 50 is 25 times 2. So the 25 will come out as a 5 and the 2 will stay. So this is going to be plus or minus 5 square roots of 2 when I simplify it all the way. Alright, here we've got z squared plus 3 equals 0. If I want to try and solve this one, I'm going to subtract 3 from both sides. I want to isolate the squared. So z squared equals negative 3. If I square both sides, square root both sides, notice that's a negative with a square root. So if you're forced to give an answer, you bring out the I, and it's going to be plus or minus I square root of 3. You just be real careful. If they want the imaginaries, then you're going to list that. But if they want just real number answers, then you would list no solution for this one. Alright, on this one, we're going to need to subtract 98 from both sides. Again, I want to get my squared term by itself. So I'm going to subtract 98 from both sides. So 2w squared equals negative 98. We're going to divide both sides by 2. So w squared equals negative 49. We will square root both sides, so w comes out. And then the the negative will come out as an I. And the square root of 49 is 7. So that's going to be plus or minus 7i. Alright, let's look at the next page. So you can see in the example on the next page how they did the plus or minus, and then they used the I. So a lot of times that's what you're going to have to do on these if you end up with a negative for a square root. And all of these are going to be, since they're quadratics, all of these are squares. Alright, x squared minus 45 equals 0. We're going to add 45 to both sides. So we get x squared equals 45. And then to solve that, we square root. So x equals plus or minus the square root of 45. Well, I think about 45, and that's 9 times 5. So the 9 comes out as a 3, and the 5 will stay. So that's plus or minus 3 square roots of 5. Not so bad. Now look at these next ones. These next ones, I have an expression in parentheses squared. Well, we're going to do the exact same thing. I'm going to just square root both sides. So this time, a t minus 4 comes out completely. And then I have plus or minus square root of 15. Don't forget there's a plus or minus there. Now, I can't simplify square root of 15 anymore because there's no perfect square that goes into it. But I do need to solve for t, so I'm going to add 4 to both sides. So that means that t equals 4 plus or minus square root of 15. Now, I don't know if we can list it like that in ALEKS, so we're going to say 4 plus square root of 15 is an answer, and 4 minus square root of 15 is my other answer. That's how I split up the plus and the minus. And you may have expressions like this that will come out to be two expressions where it's not just one happy little number. Okay, this next one, m squared plus 2m plus 1 equals 12. First of all, I need to move the 12 over. Let's move the 12 over. So m squared plus 2m minus 11 equals 0. Now, I don't know that I can factor that one, so we're going to come up with a different way to find a quadratic, to solve this kind of quadratic later on. So I'm going to save this. We're going to save to use quadratic formula. And you're going to learn that in another section, and you're going to love it because we're going to sing. Let's look down at the bottom of this page. All right, let's do this one. If I didn't want to use quadratic formula, if I really want to be forced to use square root property, if I leave it like this, and we're going to learn a couple of different ways to solve these. So I'm going to go ahead and on this one, you see how they factored, and they've got m plus 4 squared equals 40 on the left side. Well, factors of 25 that add up to 10 are 5. So that would be m plus 5 equals 7. So that's really m plus 5 squared equals 7. Then you could do like we did over the top and square root both sides. So m plus 5 equals plus or minus square root of 7. And then move your 5. Now, this is not, I would only, so m equals negative 5, be sure you get a negative with that one, plus or minus square root of 7. So that's negative 5 plus square root of 7 and negative 5 minus square root of 7. Now that's not the normal way I would solve that particular problem. You'll learn in another section using quadratic formula. But if you're specifically asked to do square root property, then go that route. If not, I'm going to give you 3 different ways to solve these, and you can choose a way to solve these. You can't use square root property on everything, but if it's an option. If it were already solved like this, I would go with square root property. But if it looked like this, I would use another method that we're going to learn in just a few minutes. All right. Option 2. So we did square root property in the first part of this section. Now we're going to do something called completing the square. Now, completing the square can be a little bit more daunting, and so you're going to have to pay close attention to what I do in completing the square. First, as a review, remember if we have a perfect square trinomial, if I find factors of 1 that multiply to get 1, but that add to get 2, that would be 1 times 1. So this is m plus 1 times m plus 1, which I can shortcut and write it as m plus 1 squared. Same thing for this next one. If I want to multiply to get 49, but I want to add to get negative 14, I would do negative 7 and negative 7. So that's x minus 7, which equals x minus 7 squared if I want to rewrite it. So a trinomial that's perfect square, what I'm really doing is I'm taking half of this middle term and squaring it to get the 49. Half of 14 is 7. 7 squared is 49. I don't like you to have to memorize this stuff in the middle. So here, let's just do our fill in the blank. Because what's going to be important about completing the square is being able to fill in this part right here. So if I want to do x squared plus 18x and I want to fill in this next part using this formula above, if I'm trying to make a perfect square trinomial that will factor, I'm going to take half of 18, and that's 9, and then I'm going to square it. That gives me 81. So x squared plus 18x plus 81. And so, in some of your problems in Alex, it may just ask you to just fill in that blank right there with the 81. Here I've got negative 24. So I want to take negative 24. I want to divide it by 2. That gives me negative 12. If I square it, that gives me positive 144. Incidentally, this will always be positive at the end because you're square a negative, you get a positive. If you square a positive, you get a positive. So y squared minus 24y plus 144 would be the perfect square trinomial. Now, I don't like throwing in weird ones that don't divide, but just in case you see one, if you had a 13, 13 divided by 2 is 13 over 2, and if we square that, we get 169 over 4. So that's what would go here. T squared plus 13t plus 169 over 4. I don't like doing those, so you won't see fraction ones like that. I like doing the even ones because it's just, you know, this is a 100 class, and I think we just need to try and keep it simple. But here again, in case you get one in Alex, if you have a number in the middle that doesn't divide by 2 evenly, for instance, x squared plus 3x plus n, I take 3 divided by 2, which would be 3 halves because it doesn't go evenly, and square it. That would give me 9/4. So x squared plus 3x plus 9/4. Now, taking it a step further, what does the perfect square trinomial look like? Well, the perfect square trinomial is going to be what this half was before you squared it. So x plus 3 halves squared. It's the square root of the 9 over 4. All right. So let's do completing the square. Here are your steps. We divide both sides by the leading coefficient. So on these, you can only have a 1x squared in these. They're not going to work otherwise. So you need a 1x squared. Isolate the variable terms on one side. So bring everything over to one side of the equation. We're going to set equal to 0. Add the square of 1/2. So I'm going to take 1/2 of the middle and then add the square. Then we're going to factor it and then use the square root property. So let me show you. First of all, I'm going to, this is set equal to 0. We're going to move the constant. So I need to move the 24 over. So x squared, I'm going to subtract 24. X squared plus 8x equals negative 24. Okay, move the constant over. Now, I'm going to take half of the middle term, that equals 4, and square it, so that equals 16. So x squared plus 8x plus 16 equals negative 24. I added 16 to the left side, add 16 to the right side. You have to do the same thing on both sides. Now, factor the left side. It should be a perfect square trinomial. The square root of 16 is 4. So this is going to be x plus 4 squared. The reason I know it's a plus is because everything else is a plus. Then negative 24 plus 16 is going to be negative 8. Now it looks like the ones we did at the beginning of this one where we did square root property. So square root both sides. So x plus 4 comes out. The negative comes out as an I. And then 8 is 4 times 2. So the 4 comes out as a 2 and the 2 stays. So I have x plus 4 equals, don't forget your plus or minus, 2i square roots of 2. Now solve for x. Bring the 4 over. So x equals negative 4, because I had to subtract 4, plus or minus 2i square roots of 2. Whew! That took a lot of work, didn't it? Okay, so again, divide both sides by the coefficient if we need to, because we need a 1x squared. Then, if it's set equal to 0, move that constant over. Then we're going to do the half of the middle term, add it to both sides, factor it because you should have a perfect square trinomial on the left, and then use the square root property. Let's do one more. Alright, I need to move this 20x over with the 4x squared, so I'm going to subtract 20x because I need it over here so I can have a middle term. So 4x squared minus 20x equals negative 14. Now I need a 1x squared, so I'm going to divide everything by 4. So that means that x squared minus 5x equals negative, that'll reduce to 7 over 2, negative 7 over 2. Now, take negative 5x, so negative 5 divided by 2 is negative 5 over 2, and square it. So that's going to be 25 over 4. So I'm going to come up here, x squared minus 5x plus 25 over 4 equals negative 7 over 2. Now this one's got lots of fractions in there. I don't plan on trying to give you a lot of fractions, but you're just going to have to bear with me. Now, if I want to factor this trinomial right here, look at what I had before I squared it. I had a negative 5 over 2. So x minus, because I have a minus here, the square root of 25 over 4 is 5 over 2. So that's what's going to go here, squared, equals negative 7 over 2. So now we're going to square root both sides. So x minus 5 over 2 equals, bring out the I. So I'm going to have an I plus or minus, and then it's going to be square root of 7 over 2. Add 5 over 2 to both sides. So I've got 5 over 2 plus or minus I square roots of 7 over 2. Now, I cannot leave that square root of 7 over 2. I can't leave that 2 is in a fraction because it's a square root of a fraction. So I'm going to come up here, square root of 7 over 2. Let's rationalize it. So that's square root of 14 over, that would be square root of 4, which is 2. So I really have 5 plus or minus I square root of 14 over 2. Whew, that was a doozy. Completing the squares can be kind of daunting, so don't let them throw you off. Alright, so that's square root property, and that's completing the square. Let me know if you have any questions. I want you to have a wonderful day.